I'm looking at a price tag here that it feels like a typo. $832. And that is the discounted price
For a computer cable.
for a single DisplayPort cable.
Oh.
The Kramer CLS-AOCDP UF-328. Now, I mean, I know high-end gear costs money, but for nearly $1,000, I'm sort of expecting this thing to make me breakfast. What are we actually paying for here?
You're paying for physics mostly, and the fact that this cable is 100 meters long.
Okay, 100 meters, 328 feet. That is a long run. But I can buy a 300-foot spool of Ethernet cable for, a fraction of this. Why is a video cable so different?
It comes down to bandwidth. I mean, an Ethernet cable moves data, sure, but uncompressed 8K video requires a massive pipe.
How massive are we talking?
Specifically 32.4 gigabits per second. And when you try to push that much electricity through a copper wire for 100 meters, the resistance just wins. The signal, it essentially evaporates before it reaches the other end.
So standard copper is just completely out.
At that distance, totally. That's why this is an active optical cable. It uses light.
Right, fiber optics. I get that fiber is the gold standard for speed. But the spec sheet calls this a hybrid cable. It says there are 4 glass fibers and 8 copper wires inside. If fiber is so much better, why keep the copper?
That's the really clever part of the engineering. Fiber is brilliant for blasting heavy video data in one direction, from your PC to your screen. But DisplayPort isn't a one-way street. Your monitor and your computer, they need to have a conversation.
You mean the handshake stuff, like figuring out the resolution.
Exactly. The EDDI data, HDCP, copy protection, all that. The computer needs to ask, hey, what can you handle? And the monitor has to reply. Doing that two-way chatter over pure fiber requires, well, expensive, power-hungry transceivers at both ends.
Usually those bulky power bricks, right? I've seen optical cables that need their own USB plug just to turn on.
Which is a nightmare if you're trying to fish a cable through a wall or a conduit.
Yeah, of course.
So by keeping those 8 copper strands for the low bandwidth talkback and for power, Kramer solved that problem. The cable just pulls the tiny amount of juice it needs, less than half a watt, directly from the DisplayPort slot.
So that makes the installation a lot cleaner. You just plug it in like a normal cord, and all the tech just happens invisibly.
And it stays thin. The whole thing is only 4.8 millimeters thick.
So we've got a cable that acts like copper but performs like fiber. It's hitting that full DisplayPort 1.4 spec that's 8K at 60 hertz.
Yeah, plus high bit rate 3 support and 8 channels of uncompressed PCM audio. It's basically a lossless pipeline across the length of a football field.
Okay, so the tech is seriously impressive. But I'm still stuck on the price. Even with all the hybrid active tech, are we just paying for the brand name?
There is one more factor that drives the cost up, and it has nothing to do with resolution or speed.
Oh.
It's the jacket. The spec's listed as low smoke and halogen free.
I saw that. Usually when I see halogen, I just think of light bulbs. I guess this isn't about lighting.
Not at all. It's about chemistry and building codes. If you're running a cable 300 feet, you aren't laying it across your living room floor.
Right, you're running it through ceilings, plenums, air ducts in a commercial building.
And if that building catches fire, standard PVC cables are a complete disaster in a fire.
Right.
They release thick, black smoke and toxic halogen gases that can incapacitate people and, corrode sensitive electronics.
So this is an integrator product. This isn't for consumers.
100%. This is designed for hospitals, convention centers, government buildings, where safety compliance is absolutely non-negotiable. You can't legally install a cheap consumer cable in those spaces. You're paying for the certification as much as the fiber.
That context really changes things. It's not a consumer accessory. It's basically construction material for data.
It really is, and it sort of signals a shift. As we demand higher and higher resolutions, 8K and whatever comes next, copper just can't keep up, especially with distance.
It does make you wonder. Right now, this is a specialized industrial tool. But as our own home bandwidth needs keep climbing, are we going to reach a point where the copper cables in our walls just disappear entirely?
We might. The future of connectivity is looking a lot more like glass than it does like metal.